Am I audible? Hello. Hello. Am I audible, friend? Hello. Am I audible? Hello. Am I audible, friend? Hello. Hello. Am I audible? Hello. Hello. Am I audible?
Yes, sir.
Yeah, yeah. Okay, okay. We'll start now.
Okay, sir.
Yeah. Good evening, friends. Uh, See, we are talking about the pipe plant. We have seen the how the plain pipe is manufactured. We have seen the all details about the extruder, the plant, and what are the inline accessories required for the pipe plant. Also, we have covered the corrugated pipe manufacturing process. Corrugated pipe die, right? All are the same. Only the you have to create the tube and then you have to overlap the second pipe over that. So, Fred, we have seen also how that the double wall corrugated pipe is manufactured. Now, today we will see these applications of this corrugated pipe as well as the extrusion, the application of the extrusion. And after that, we will see again 1 to 2 video of the pipe plant. And afterwards, we will start today the blown film plant, right? How the film is manufactured, what are the materials, what are the criteria of the materials, and how that plant is set up, how to start the plant, and many things. We have also seen the how the plant pipe plant is going to be start, right? The threading of the pipe plant, how it is from initial how what type of skill required there, right? And how they are sealing the first by that wire or maybe strings, and there may be the sliders or that they're blocking the ear. That plug is there, and that plug is blocking the ear, and therefore the pipe is not collapse at the exit of the pipe. Now, friend, what are the application of these corrugated pipes? First, the conduits for the cable protections. Yes, the conduits. We have seen that the many cables are get covered by these corrugated pipes. Then TV, telephones, glass fibers, power control, and computer lines. Then automobiles, machines, and even many planes also. Protective pipes and conveyor pipes. Then after that, we have seen the drain pipes for the fields, streets, squares, and houses. Pipe for vacuum cleaners, washing machines, dishwashers, medical applications, drip irrigation, hoses for the field, hot hoses for plantation. Then protection pipes for district heatings, domestic connection lines, structural and civil engineering. Large size pipes, large size pipes for sewage, wastewater control, shaft, and the conveyor pipes. Therefore, friend, corrugated pipes are produced with a diameter from 3 by 5 millimeter to 2000 millimeter. Such a huge structure we can manufacture by using the uh, you know any pipe manufacturing process. Now these are the applications of the corrugated pipe. We will shift to how these pipes and tubing differentiate. I told you the pipe which have a 12 mm diameter, that is called as a tubing, and above that diameter is called as a pipe. Here, if the uh, improper die or screw design, poor output, then ensure die and screw are designed for the desired outputs. Then suppose inside diameter having a blisters, ID having a blisters, then is a insufficient vacuum, therefore increase the vacuum. These are the remedy for that. Therefore, generally, the troubleshooting is same for the pipe and tubing friend. Then excessive moisture, then maintain normal percentage of moisture, then gases entrapped, reduce the temperature, water inside the pipe, stop water access. These are the remedies for that. The inside diameter burn streaks. There are burn marks inside the diameter in the pipe. Mandrel heat too high. Whatever we are using the extended mandrel, that may be heated, and that heat may be very high. Then check mandrel heat. Stock temperature too high. Therefore, see the temperature, barrel temperature. See the initial temperature. Then reduce temperature slowly. Then uh, see the grooves, ID grooves, they are not proper. Then mandrel is coated with a material. Then clean the mandrel. These are then wavy surface generally occur on the pipe surface. Then you have to check the cleaners set improperly. Then adjust the cleaners, puller drive slipping. Then adjust or replace the puller drive. Then burn sticks, that is again material hung up on the die. These are the that why these burn marks are observed, because of the material get burn inside due to the high temperature, and that's why you have to reduce the temperature. Again, if there is a burn mark, you have to clean the die. Now, many times, if you observe the outside surface of the pipe, that is uneven circumference. That means there is a wavy nature. Therefore, this thing happened due to the too much air pressure on puller or insufficient air pressure. Therefore, you have to use the optimum air pressure. Therefore, if it is high, you have to reduce. Therefore, you have to always check the air pressure in the pipe. Then discoloration. Suppose if you see the outside diameter, you are that pipe surface, you are expecting that a light red color, but it may be having some dark red color. Therefore, why this happen? This is happened due to the stabilizer level too low. Therefore, check the stabilizer level. Then again, air bubble. If you see the pock marks, there are the pock marks always observed on the outer surface of the pipe. How can you overcome that? And these air marks, the pock marks are observed due to the air bubbles adhering to the pipe in a flotation tank or improper adjustment of the spray rings that surround the water tank. These are the main fault, and how you to overcome. You have to install the wiper in a tank, or you have to again adjust the spray rings. Spray rings are there, you have to adjust that properly. Otherwise, these pockmarks are always on the pipe. Then suppose outer diameter is oversize. We want suppose 100 mm outer diameter, but it's oversize, maybe 102, 103. That time, why this happen? Due to the air supply too high. Whatever the air you are supplying through this die, right? I have shown you the die where we drill the hole to the die through the spider leg in a 90 angle through the mandrel, and through which we are passing the compressor air. This air is a very high. If this air is very high, then the pipe size will increase, the diameter will increase. Therefore, adjust that the air pressure inside the pipe. So second possibility is that insufficient water supply. If the water supply is insufficient, right, to cool the water, that pipe, then again you have to increase the water supply in the cooling tank or maybe in that uh, sizer, pipe sizer unit. The third possibility is the pipe hot when measured. When you measure the pipe diameter, it is very hot that time. Allow pipe to cool and then measure. Okay, generally people have a very, in a rush, when the pipe coming from the die, they start to direct uh, measuring the pipe diameter. Fred, don't do that way. You have to wait and you have to take the diameter, but where the pipe cut, that time you have to take the diameter, or there may be a diameter, that beta gauge. You can easily measure the diameter of the pipe by applying, by installing that machine at the online before the cutting. Then wall too thick. Suppose you are manufacturing the pipe and the wall, whatever you want, suppose you want to 3 mm, but it is showing you 5 mm. Why this happen? Because of the misadjust die bushing. I have shown you that day, die bushing and centering. There are two centering screw, right? We can easily give the movement to the bush by that centering screw. There are two centering screw. I have shown you that E and F, right? E is used for the centering the die, and the second one is the for bushing a ring, right? We are applying the that a ring at the outside of the bush, right? And if you are not properly misalignment is there, then there may be higher thickness possible. Hence, we have to adjust that bushing properly by using the centering screw. That is also called the wrong die setup. You have to use the correct die setup, right? Therefore, bushing, there is a complete equal annular gap between the die bush and the bed. Now, friend, how the Teflon pipe is not possible by our extrusion process, how it is manufactured. I'm going to show you some video here. You can see this video also. See here, the extrusion of a Teflon is a very difficult, friend, right? And therefore, we have to suppose manufacture the uh, Teflon pipe. Teflon pipe, you know that it is a very material that is require a lot of force. It is highly viscous polymer. It is a very highly viscous polymer, friend, and such a polymer you have to manufacture the product or maybe pipe. How can you process it? See, this is the a method how the powder is get poured inside the that machine, and how it is how do you manufacture that Teflon pipe? This is a very unique process. You can see now. See how the piston is pushing the material, how the piston is pushing the material inside the die, right? If you see here, how it is a that pushing heat material. This is the ramp from the top, and see the die is having a movement there, that hopper, and they are just pushing the material inside the barrel. Barrel is heated by a different type of heaters, and see a complete parison type of things that are coming down, right? See now, here it is just pushing downward direction, and you are getting the Teflon pipe. You cannot extrude by the using by the extrusion process. So, my friend, this is a very unique process to manufacture the Teflon pipe. Now, what are the applications of the extrusion? See here, uh, blown film, cast film, co-extrusion film. We are going to take this now. After finishing this corrugated pipe, we are just talk about the corrugated pipe now. Now, we are going to uh, talk on this blown film, how the blown film is manufactured, cast film is manufactured, all these things where how it is the manufacture, which are the materials, PP, PVC, LDP, SDP, PET, and nylon. And how these are manufactured, we are going to see. Then pipe and tube, just we have seen now, these are the material used for the pipe and tubing. Then sheet, we are also going to see how sheet is manufactured after our blown film plant. We will cover this also. These are the materials for sheet. Monofilament frame with PP and nylon filament generally used in the market. Many, that there are many customers for PP and nylon. Lot of applications are there, this monofilament. And this are also we are going to discuss. Then extrusion coating laminates. Yes, we are also going to see that coating, wire plant, cable plant, right? Then we are also a box trapping, going to see then woven stacks, a wire coating, covering, primary and secondary insulation, and the profiles, various type of profiles can be manufactured. Maybe I told you various type, L type, Z type, U type, W type, any type of a continuous profiles can be manufactured by the extrusion process. These are the very major application of extrusion process. I have like one video you can just see now. Then we will shift. It's a extrusion process, just ram extrusion. See, these are the various profiles we are going to, extrude by this. Then blown film also. Even these are the various profiles we are going to see. These are the blown film we are going to also see just now. After this, then these things we have seen all fit zone, melting zone, right? Also, uh, we have seen this also. Then we have seen the pipe plant, friend. Then these are the different type of accessories used with the pipe plant. We have also seen this thin extrusion die, right? And we have also seen the vacuum calibration, pressure calibration, right? Here two type of calibration for the pipe, right? See here, water outlet, water inlet. And this is the called as a pressure calibration. See, water is at the top. a pipe going through the inside the sizing unit. Yesterday we have seen this, friend. Okay, and here, see, here we are, here we are, inserting the a compressor here, right? To avoid the, this is a, and it's a plug, right? Due to this plug and this compressor here, the pipe do not collapse here, friend. Generally people are thinking, why the material is not collapsing in the sizing unit? Because see now it is very close to die, right? And hence why it is not collapsed, because of the we are passing here compressor here and the plug at the front. Therefore, due to the plug, the air cannot escape from the pipe, right? And therefore your dimension of the pipe is maintained. Now see here a vacuum calibration. Vacuum calibration, here see the vacuum is created over this water, right? Right, this is a tank. Water is there. And see now here, this is a perforated sleeve. The sleeve is how is a perforated. You will get completely shining at the top of the pipe. And this is a vacuum sizing unit. It is also used on a large scale in the market. Now, these are the used for the different type of profiles, right? These are the all the very, all the dimension and many things are there. Uh, the design part, friend. Okay, we are not going to cover because this is a very large part, friend. It is not possible to, you know, to reach there. Yes, we have seen this. Now I'm going to show you one or two again the video of this corrugated pipe, and then we will see the a blown film plant, how the film is manufactured. Just wait 1 minute. Let me share the other PPT. Okay, 1 minute. Wait. Am I audible to you? Hello, hello. Am I audible to you, friend?
Sir,
Yes. I have share one a screen. Is it visible to you?
yes, sir, it's a blue film extrusion.
Yes, correct. See, I am going to show you a one to the video here of a corrugated pipe, and then we will go on this blown film plant. Okay, so that you will get the more and more ideas. The latest machine, extrusion machines nowadays, all many are from the Korean made, Japan made, maybe some China made company. See now here how he is showing the demo of the corrugated pipe. See now these are the die for the corrugated pipe, right? See here you can there are number of blocks are there. How the blocks are get you know, with the pipe coming from this. There is some maintenance because you have to, the block should be move smoothly and get a right structure to your uh, the outer side of the pipe. See, here the maintenance is going on and how the blocks are get arranged and how they have got rotational motion, right? See this, this is a now a demonstration how to start the plant, right? See now here, corrugated pipes. That pipe we are using for the our, you know, see now here now how he is putting some one, rod there, and he is now see now the rod came here now. See this is a rod. See now he this when the pipe coming up, it, that will go on this, and it will act as a plug for that. And they are now putting the ear inside the pipe. See now, it is the threading now. See now, this is a plug. ओके, दिस इज अ स्ट्रिंग, एक धागा है देखो यहाँ पे, राइट, वायर, स्मॉल वायर है, कॉपर वायर जैसा. एंड सी नाउ हियर how he is threading now, how he is starting the plant. See here. And now when the material will get attached to this plug, and it will go, in the front direction. See, now this is called as a threading of the pipe. How to start the pipe plant. See now here, how they started. See, this is a die here, the material coming through this. See, the plug is here, and how that is the material going over. See now here, this is the rod. See now, the material now coming here. Now see, this is a uh, see now here. See, this is going on now. Correct. See here, how these things happening here. You can see easily, and you will get a completely corrugated pipes, friend. Corrugated pipes. The pipe which have a, uh, it is act as a spring. We can use this pipe for the many, that drainage purpose. Uh, Many household applications we are using this pipe, right? See how they put the mark of the die on the outer side of the pipe. There should not be any leakage or breakage of the pipe. See, now they are checking. Is there any, that dye mark, or maybe any pock mark, or maybe any leakage of the pipe? They are observing now. Because it is in a hot condition, maybe the mode may be damaged that pipe. You have to check up that. This is a friend, polyethylene material. Remember this thing. And polypropylene. See, there's a winding roll is there, and on that the pipe get wounded. See, the same thing is there. There are different zones, 3 zones are there. Nothing new is there, friend. Only this type of a circular, that rotational type of die, they are using to sizing purpose. See, these are the blowers. Here the die having a water. It is get cooled by the water. See the winding station. The pipe get wound here, friend, for the dispatch section. Again here another, see here another, plant is there for the extrusion. It is a new plant, friend. The China-based plant. See how they are now do the threading here. See the dye is here, and same thing is there. Nothing is no change at all. See here that how they are get rotated. The blocks are get rotation. These are the all on-off unit. These are the all parameters, setting parameters, temperatures, speed of the screw, the sizing unit is there. See now here, it is actually, see how the corrugated pipe, you know, manufacture. It's a polypropylene pipe frame, PP pipe, which are generally used for the, and it's a cheaper one because see, you are saving the material also. This corrugated pipe is a light one and you can save material. It is a flexible pipe. You can use anywhere, friend. Low weight, even it is also get floated on the sea also, friend, because it is a completely uh, light one. Because if the PP density is less than 1, see now, initially it is a transparent, then afterward it will become some opaque. In hot condition, it look like a transparent. See how they have made the provision to up and down. See, there is a how the pipe is there inside, and it is a guiding over that pipe. The material is get coated, and that not coated. It is the pipe is manufactured by using that small type of rod. See, the die is here, friend. This is a band eaters. This is extruder. See, very small extruder. Okay. It is a single screw extruder, friend. It's a hopper dryer. It's a corrugated pipe. It is a pallets and master batch is there. Polypropylene pipe. How does it get mixed? See now the material is coming out through the die. See, different type of design is available there to manufacture the pipe. See the die, how the blocks are opening there. And it is get pull. See the pulling. See the system here, friend. How it is get. See again there is a how they are keeping the wrapping of the Teflon film. It will have a specific application. The sealing is also there. This at the top, it is sealing also here, friend. Wrapping and slim, sealing. See now, the same thing get wounded here now because it's a flexible pipe. There are number of winders are there, twin winder, right? Just removing the one side. There are again putting the another one there. The automation there, friend. It is a completely automation. Again, the bundle is get wrapped with the Teflon film or maybe polyethylene film, and it is get transported. See how they are cutting the pipe. See now here how they are cut the pipe manually. See the shining inside of the pipe. They are taking the testing of that, how much compression strength is there. So friend, we will start now the blown film extrusion, right? Any difficulty, friend? You want if you want to ask any question about the pipe plant, you can ask me here. Hello, am I audible to you?
Yes,
Hello.
sir.
Yeah.
Yes, sir. Yes, sir. Yesterday I have asked 3 questions.
Uh-huh. Yes, correct. Now, friend, today we have finished our pipe plant. We have seen a lot of possibility, lot of structure and many modification in the pipe. They are troubleshooting also and applications and many things, friend. Even design of the die, right? Today we're going to start the bloom film extrusion. We have a extrusion topic, and we are going to cover many extrusion plant. Now we have already completed pipe plant, corrugated pipe plant, plain pipe plant. Now today the blown film plant. After blown film plant, we are going to sheet plant and many more. Wire and cable plant also. Now see here the blown film generally. How can you define the film and sheet? Uh, generally, what is the definition for film and for sheet? Can anybody tell me? Film and sheet. See, generally what happened, the film having thickness less than 0.25 mm and above 0.25 mm, thickness is called as a sheet, right? Above 25 mm, it is sheet, and below 0.25 mm, it is a film. Now here we are manufacturing the film frame. Okay. Now again the same here. If you see here, here the extruder. Now see, extruder is the now at the ground side, very close to ground. See, these are the hopper, heaters are there, drive system is there. See the screw for the process, blown film plant. And if you see here, die is there, friend. This is the cross-head die now. In pipe plant, we have seen the straight through die. Now you see, now here is the cross-head die. Material coming like this and going like this. And therefore, this is 90 angle, right? If you see here, the 90 angle. Extrusion, we have seen a straight through die for the pipe. Okay. If you, there, the material flow straight, like this straight. This is a barrel, this is a die, and it is a sizing unit, cooling unit, like that. But now, if you see here in a blown film plant, the material get diverted in the 90 angle. Okay, see, this is a 90 angle. And this is a die ring. Okay, and here is also a die. Here is a die body is there. Through the ring, here the material get blown in a annular gap between the among this mandrel and the ring, right? And then friend, it is get that threaded like that. This is a wooden, you know, collapsible frames are there, and both side. These are nip rollers. One is a rubber roller, there is a stainless steel roll, and see it's a guiding roll. As the roller is there to for the winding purpose. This is a very simple, diagram. You can easily draw this diagram. Now here, the collapsible this frame will give the actual shape to this uh, bubble, and it get collapse here because it is called as a collapsible. Here film is get collapse here, and you will get a two, after folding here at the nip roll, right? It's a nip roll. The height it also varies as per your production, as per your bubble, as per your material. And this guide roll guide this a layup, flat इसको बोलते हैं flat layup. This flat layup film, and again it is get wound here, friend. The bubble, this we will discuss, going to discuss these details now in the next slides. See, now we have seen the extrusion blown film plant. Now upward blown film and downward blown film. If you have seen here, it is upward blown film. Now, in many cases, the extruder is at top, and this it is at the downside. That is called as a downward extrusion. This is called as a upward extrusion. Now, why this happen? See here, upward blown film and downward blown film. Now, which are the material which can be blown upward direction, upward? AD, lower density polyethylene, high density polyethylene, PVC, nylon. These are the material can be upward blown, right? Upward blown. Now, if you see the downward blown film, there is only one material, that is the polypropylene. That is a polypropylene. Now, can anybody tell me why PP is uh, why PP is downward flowing, downward blowing. Can anybody tell me? Why PP is downward blowing, friend? It is not upward blown. PP का film downward blowing करते हैं and polyethylene, nylon, PVC का film upward blowing करते हैं. Can anybody tell me why this?
So PP having low density.
Yes, pardon, please. You see, correct. It PP polypropylene don't have a melt strength. Once it is a melting strength is very less, and therefore, see the density of melting strength of this polymer is very high. But this polypropylene it easily get it is a shear thinning. It is what a shear thinning property shows, and therefore that's why shear thinning. We have seen shear thickening and shear thinning, right? Non-Newtonian fluid. Every plastic is a non-Newtonian fluid. It shows a two flow. One is shear thickening, other is a shear thinning, right? Shear thickening. These polymers show shear thickening property, and means by shearing they get thicker. But see this material by shearing it become a shear thinning. पतला पतला होता है एकदम polypropylene, and that's why it is a get blown downward direction. Okay, now see at the process made emerging from the extruder is inflated by air pressure. See here how much air pressure used 3 to 4 kg per centimeter square. See bubble के अंदर हम लोग air डालते हैं, right? And that air, how much air we are putting there? 3 to 4 kg per centimeter square. Friend, it is a very important. There is a one pump is there by which, or maybe there is a compressor is there by which we are allowing the to inflate the bubble, right? Here we are putting here a air from the downward direction, and that air may be 3 to 4 kg per centimeter square, right? By the compressor air. Bubble is properly stabilized. Bubble को एक अच्छा round आता है. Then it is a cool. Why? It is a cool by this cooling ring. There is a blower. Blower is here, and that blower will cool this bubble. यहाँ से उनको hole होता है यहाँ पे. There are number of holes around this circumference of this air ring, and through that a compressed air, a blower will pass here outside of the bubble, and therefore bubble easily cool, right? There are many provision. There are number of process for the cooling of bubble, right? Even inside also the mandrel is there. Many times it is there, and it is get cool. Bubble get cool there, friend. Cooling is very important, friend, here. Okay. Now wound on the winder. I told you there are winders are there. Surface winding. There is also contact winding is there. Surface winding. I will tell you that what is the difference between surface winding and the contact winding. Now, friend, I will take 2 minute break here, and then I will come again here, friend. Just 2 minute break. See now, friend, here the winder. There are two type of winder. One is a surface winding. Second is a contact winding. Okay. Now we will take in details afterwards about the winder. In a blown film extrusion, a tube of a plastic material is extruded out of the die. Right? Just like pipe. Just a tube is coming outside the die. But die here across a die, I told you. The material flow in the 90 angle. The here die is a round one, right? Having a earring. Therefore, friend, while it is at the blown into a bubble, then it is cool. Then when it is again bubble form, then it is cool. The bubble is inflated by air pressure. I told you there is a compressor, and from the down there is a the pin is given to pressurize the bubble. Then it contained between the die and the setting provided by the nip rollers. The bubble is flattened by a pair of collapsible frames. Yes, I told you here at the top, below the nip rolls, there is a wooden collapsible frames are there, and that frames will guide, which will help to collapse the film before you pass through the nip rolls. Therefore, it is just guiding purpose. After guiding that, it get a completely, that's why it is a collapsible. The name is collapsible. It will collapse. It will the film is get collapsed, dear friend, by due to the presence of the wooden frames, and then it is a very easily passed through the nip roller. See here, these are the nip rollers, right? Here, the film is get collapsed here, and then it is a passing through this. There are counter rotation. If this rotate like this, and this rotate like this. One is stainless steel roll, and the other is a rubber roll. Therefore, there is a grip. There is a no. Many times people they are in a mind that the ear here it will go like this, but where it will go? It can't go anywhere because the rubber roll is there. Therefore, either ear will cannot escape from this. Once you pass here the ear 3 to 4 kg per centimeter square, that ear maintained their friend. Even after that passing ear, it is get heated and it is also expand there inside the bubble. Therefore, you have to control that. What is the compressor ear? But it is not escape from this bubble. Now, if you see here, friend, I told you it is a upward frame downward. Now the film blowing operation can be accommodated by theoretically. It is also horizontally possible, vertically upward. I told you for SD, polypropylene, not PP, PVC, nylon, we can the upward, vertically downward, only for polypropylene. Okay. Now see, this is the plant here. See the die is here, hopper is here. The same thing, nothing changed. But here the screw may be changed as per the design required for the blown film. Right. See the bubble here. It is a very heighted. Here is you have to pass here, compress here, downward direction. By the bubble is get inflated. Collapsible frames are there, and it is a guide roll or idler roll is there. This is a lay plate. It's called as a lay plate because there is a the film is get collapse here. See, and that is why it is called as a lay plate film, right? And there is also a guiding roll, and there is a winding is there. Okay, it is a very important frame. See this diameter of this thing and diameter of this is very important. Diameter of bubble and diameter of the ring. It's a very important frame. See now here. The choice of any of the other of the three methods is directed by the plastic material and the process limitation. See here, friend, the bubble coming through this. There are something, the blow up ratio. The blow up ratio play very important role here. BUR bolte usko. What is the blow up ratio? Bubble diameter divided by the diameter. See, this is a bubble diameter here. Bubble diameter divided by the diameter. This will give the BUR. Many times when you buying the film, even if you buying the machine, how much the BUR possible, right? BUR. BUR is very important. Blow up ratio, right? So friend, now what is the blow ratio? What is my blow ratio? See, blow up ratio and blow ratio, both are different. Blow ratio means what? The lay flat. See, यहाँ पे वो फोड़ हो गई है. Film is get poured here, friend. These are the nip rolls, right? These are the rolls. See, the film is now here. The bubble is there. It can collapse due to the wooden frame. यहाँ पे दिखाया नहीं वो. But see now here, there are nip rolls. One rubber roll and one is a stainless steel roll. Now, see, this is called as the lay flat width. Lay flat width. Right. This is a see transfer direction. See, this is what a transfer decision, and this is what a machine direction, right? Machine direction. This is a film. The film is machine direction, and this is a transfer direction. Okay. Now, friend, see the blow ratio. Blow ratio means what? Lay flat width. See, this is a lay flat divided by the diameter of the die. Very simple thing. Therefore, these things generally you use in the market. Lay flat width divided by the diameter of the die. This. And this is called as the blow ratio. Therefore, blow ratio and blow up ratio. These are the two important factors here. Now, can anybody tell me where is the highest strength here, friend? What is the highest strength? Here, machine side or this side? If you see, if you just apply your tensile strength here and here, which give the more tensile, this or this? टेंसाइल स्ट्रेंथ ज्यादा कहाँ मिलेगा? इधर मिलेगा, इधर मिलेगा?
हॉरिजॉन्टल में मिलेगा सर.
हाँ, इधर ऐसा.
एमडी साइड, एमडी.
दिस साइड.
हाँ.
Correct. Because the chains are, you are 100% right. See, the chains are get elongated this way, right? Elongated this way. Even आप थैली में ले लो, right? थैली का आप देखो, उनका जो जहाँ उनका ये होता है पकड़ने का, वहां पे स्ट्रेंथ ज्यादा होती है उनका. But if you see the transverse side, this side, it is it is easily break, right? Easily break. See, because of the alignment of the chains in the direction of the force, and therefore orientation is a very good here in this side, and therefore machine direction always give the higher tensile strength. Correct. Machine side give the always higher tensile strength. Therefore, friend, generally this is a upward type. Generally, horizontally we are not using actually, but downward I told you only for polypropylene, right? Therefore, friend, the upward blowing is a very good for polyethylene and PVC, right? And I told you the vertical downward is only for if you want to higher clarity. देखो polypropylene का film आपने देखा होगा, ये तो बहुत आवाज करता है वो film. आप and it's a transparent, completely crystalline transparent पीपी फिल्म. ये कैसा आइडेंटिफाई करने का इजीली? एकदम ट्रांसपेरेंट फिल्म रहेगा तो बोलने का पीपी फिल्म. ओके. इतना इतना ट्रांसपेरेंसी पॉलीथिलीन के पास नहीं है, पीवीसी के पास इतना नहीं है क्लियरिटी. इट इज ओनली पीपी फिल्म फ्रेम. and तो जनरली वो आवाज देता है बहुत. फॉर पैकेजिंग ऑफ गिफ्ट और मेनी थिंग्स वी आर यूजिंग दिस पॉलीप्रोपिलीन फिल्म, ट्रांसपेरेंट फिल्म फ्रेम, राइट? Here, polypropylene film, I told you that have a separate plant. क्विंचिंग होता है, वो क्विंच करना पड़ता है, बिकॉज क्विंचिंग से वो चेन गेट अरेस्टेड इमीडिएटली एंड you will get a complete, there is a gap, widened windows are there, lot of windows are there. It is the clarity like a glass, right? Polypropylene film. And it is excellent, if you see the plant, you will get it is a one type of magic there. See, I am just showing you one video of that, so that you will get more ideas about the plant. See now here, friend, I will just make a sound less. See here, the film is blown film is there. See the very huge plant. It may be 2 floor, 3 floor like that. See, this is a die, and this is see earrings are there. This is a blower which will cool this bubble from the outside. यहाँ पे हवा चल रही है, आपने को दिख नहीं रहा है. You cannot feel here, but here the from the bottom the blower will they see this is Teflon, right? There are Teflon, that beads are there. See, this is a lay flat width is here, lay flat width. And see, this is a roller. Now it is a which winding, friend? Can you tell me it is a which winding? Surface winding or center winding?
Center
Hello?
winding.
No, a surface winding. Surface winding. Surface winding always give the very good winding, friend. Center winding means every bubble, every bobbin have a separate motor, and surface winding means there is a one big roll, and over that roll, other roll is get rotated, right? See, this is now here. If you see here, this roll is rotating, and this is a bobbin is only rotating. It is a no motor. See, there is a no motor here, right? This when this roll rotate, that time this roll rotate this way, and this is a very good frame. It is called as a surface winding, and this it is a tension free, stress free. You will get a very smooth, winding there, friend. And center winding means what? See, center winding means there is no this big roll. Motor is here, and the film is coming on this direct. That is called as a contact a center winding. Center winding, barabar. Oh, there are many strays. There may be many, that the contact lines are there. There may be some waviness. There may be some bumps are there. That bumps can be avoided by this surface winding. Therefore, surface winding is a very smooth winding, friend. People are using surface winding because they only, what is the difference between the, here is only a big roll is there, and this around the big roll, there are number of bobbins are there, right? Now, after this, it will get shifted here. After this, you will get shifted there, right? It is like that. You can cut easily this film, right? At how much you want the, meter, that can be wounded here. Okay. So friend, this is a very unique plant here. If you see now here, only this roll is rotating. See here, motor is there. And it is the rotated due to this roll. See here, hopper dryer is there. And see the very huge plant, maybe 2-3 floors, right? See the bubble height. Lot of big bubble height is there. It is get guided by these things. See now, these are the plant pictures are there. See now here. See the machine. See how it is that it is but it require a higher floor, that see the height of this machine, maybe 2 floor, 3 floor, like that. See, this is a ear ring is there, and this is a blower. 1, 2, 3, 4, 5, 6, and through which a very high, that ear, thanda ear, cool ear will get pass here outside the bubble, and therefore the bubble get cool easily, friend. Now we will see the blown film die. See, this is a blown film die. It is side fade die. There are two type of dies: side fade die and center fade die. Side fade die and the center fade die. If you see here, the side fade die. See now here, the material coming like this. See, this is a extruder here. Here extruder A. Okay. And see material coming like this, and it's 90 angle, right? material flowing like this, right? This is a mandrel. This is a mandrel. This mandrel is get attached to this die body with the help of from the bottom, right? There is a air pressure, right? We can pass air from this place. See the material flowing like this, and the material coming this gap, this gap and this gap, right? Here we can pass a compressed air from this side. Now, how it is a different from the centrifugal die? Centrifugal die means direct यहाँ से material जाएगा. Centrifugal die means direct from this place. See the side fed die now. This is called a side fed die. This side fed die have a lot of applications for it. See what is the advantage? Low initial cost. Adjustable die opening. Here die opening is very easily. You can adjust the thickness here. Right. Here is the center. Centering screws are here. This is centering bolt. And you can easily uh, uh, change the thickness by there is a bush. Now we'll handle low flow material easily. Low flow material can be adjusted here side fed die because the material is stable. For that purpose, you can use the side fed die. Now, what are disadvantages? Mandrel deflects with the extrusion rate. Therefore, die adjustment is essential for that. Die opening changes with the pressure. This die opening can be changed with the help of with the opening of the pressure. If the high pressure, die opening take place. Non-uniform made flow. Because see now the made is flowing like this, and you will see that it will get turning here like this. यहाँ पे उनका रेट अलग है, यहाँ पे रेट अलग है. Therefore, it is a get turning there. Therefore, non-uniform made flow cannot be rotated. This die cannot rotate like this, like this. ऐसा 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 रोटेट नहीं होती है. सेंटर पे डाई रोटेट होती है इधर क्योंकि मटेरियल यहाँ से आता है तो इट विल रोटेट लाइक दिस बट साइड पे डाई नॉट पॉसिबल. Therefore, we cannot adjust the thickness by using the side fed die. Center fed die में thickness you can arrange, friend. Now, one weld line in film, only one line because of this. Okay, only one line is possible in this case. Now, see the center fed die now. Center fed die, see where is the material? Yes, material get feed here. Here is the extruder. Okay. Now see now here, material going like this. This is like this. And this center fed die, you can rotate like this, friend. Rotation is possible. Right. Positive die opening. Yes, see that. Ekdam positive die opening hai. It can be rotated. And it can be handled, low flow regime can be handled easily. What are disadvantages? High initial cost. To fabricate and to design such a die, it requires skill and therefore high initial cost. Very hard to clean. If you want to open this, it is a very, you have to open this and then this side. Difficult to, open. Therefore, friend, this is a, the maintenance cost is high also, friend. Here, cleaning is a difficult because of the heavy things and because of again the complex things is there. Okay, then two or more weld lines in film. See, there side fed die there is only one line, but here two and two or more weld lines are there because of you are putting the material here and it will get diverted. Okay, this is annular gap, circular gap through this film is coming. Here say it is a round one, and you can rotate this. By rotation, you can adjust the thickness of the film frame. Thickness adjustment is very possible here in this case. Now, spiral flow die. This is also unique process frame. Spiral flow die. Heat stable material के लिए बहुत काम पे आती है, right? For SDP, right? High density polyethylene. See now, these are the centering screw here. See material get feed here from the bottom. Here is some grooves are there, spiral, mandrel are there, manifold die. It's called as a manifold die also. Then this is the land. Land is provided to this. It's a very unique skill design for this die. The primary land is there, secondary land is there. Now, friend, then see the exist orifice. यहाँ से material आएगा. This is the adjusting ring. The ring can be adjusted here. And therefore, you can adjust the thickness of the film. What are the advantages? No wear line in the film. There's no wear line. Generally, people are using this spiral flow die nowadays in the market. Positive die opening. Yes, we want that. Easy to clean. We want that. Can be rotated. It's possible because it's a round one. Material flow like this. Then improve film optics. Yes. ज़्यादा clarity मिलेगी आपको. You will get a clarity. Then high head pressure. See, this is the disadvantage. Because of here, very smooth material going, but there is a pressure built up due to the spiral. Growths are there. Manifold. High pressure uh, at the head it will develop. And you cannot handle here the low flow regime without modification. Therefore, it requires a high flow material चाहिए, like polystyrene, right? इसका flow बहुत ज़्यादा है material का. For such a material, you can possible. But polystyrene generally we are not, LDP. Yes, it is possible. LDP, it is a high flow material. LLDP, it is high flow. Okay, for such a it is a possible this dye, but people are using for many polymers. Now, definition of terms, I told you what is the blow ratio and what is the that blow up ratio that we have seen there. Now, the blow ratio, uh, I told you the diameter of the bubble divided by the diameter of the die. Right? We have seen in that diagram. Right? And it is generally 2:1. This is what? 2:1 generally for polyethylene material. Now, lay flat width is the width of the flatted by flat tubing. Therefore, lay flat width कितना होना चाहिए? Pi is the diameter of the die divided by the 2 across blow ratio. This ratio, and you will get lay flat width. It's easily calculation, friend. Then drawdown ratio. Drawdown ratio means what? See, it is a measure in the extent of the thinning of the wave without rupturing it. It is the ratio of die orifice gap to the film thickness at the nominal blow ratio. That is a 1. Therefore, the film thickness and blow ratio is measured like this. Drawdown ratio, die gap divided by the film thickness into blow ratio. This is a formula to find out the drawdown ratio. Now, you know that if there's a blown film plant, there's always freeze lines. Freeze lines, आपको पता होगा कि these are the here, you see here, the freeze lines are here. I will show you the freeze line here. Here is the freeze line frame. यहाँ पे आपको कुछ दिखेगा नहीं. It is not यहाँ पे ट्रांसपेरेंट है. ज्यादा कूलिंग कहाँ से हो रहा है? यहाँ से, इधर से कूलिंग हो रहा है. But here you will get you can see here completely. This is a complete transparent here, friend. Highly transparent, because here the material in a complete melted form, polymer. But यहाँ से it will get a freeze. यहाँ से वो क्या बनता है? उसका film बनता है. Yeah, the film, actual film going to made here. But here is only melt. And therefore, this is called as a freezing line. Freezing line here. And after this, it become opaque. This side, maybe contact transparency. But here is a lot of transparency is there below the freezing line. Now, if you see here, the freezing line height is the height from the die face at which the made freezes. The freeze line height affects the optical property of the film. Yes, optical property. That means transparency, clarity, and it is a since the molecular relax take place at the freeze point. Correct, because of by the compressor here, the air will remove the that heat pattern, right? Heat from the film. Therefore, from that onwards, it will get opaque or maybe contact transparency. Higher the freeze line height, poor will be the optical properties. If the freeze line, if you see, this is very important. Higher the freeze lines height, poor will be the optical property. And lower the freeze line height, brittle of the film increases. See here, both are, and that's why you have to do the optimum freeze line, right? Optimum you have to, and that is you have to adjust it, but it is adjusted by the, it is taken care by the that die designer only, friend. Okay, and how much the height of the bubble, and what type of size you want, lay flat width you want, right? Um, it is a bigger plant, maybe 3 or 5 floor plant. That bubble size play very important role, friend. Now you also go here because I have one. You will get more idea. See here. There's a die here, friend. See here, die is here. And see the bubble here. See now here. Here is a cooling take place inside. See now here. There are co-extrusion. There is a multiple die is here. And see here, a spiral die. And this is a bubble now. See the how the this is a in a mandrel friend, which will give the cooling effect to the bubble. This is a very sophisticated plant here, friend. It's called as a co-extrusion. See here, the material get loaded by the hopper loader at the direct hopper from the bean. See, this is a inside. The cooling is take place. See now bubble. See the height of the bubble is a very high height, maybe 2 to 3 floor, maybe 20 feet and more than that. This is a lay flat width. This is a guiding role. This is also a guiding role here. See here, surface winding. See the big roll is there, rubber roll, and see here the film is get wounded on this roll, not this roll. This roll rotate due to this roll automatic rotate. Motor is where motor is joined to the a big roll here. See now. Now it is a complete हो गया अभी इसका काम हो गया अभी. It will cut now. See now cut हो गया. See now it is coming down now. And the another that a bobbin which will place at here, and see now it is going on now. Winding is going on. This is called as a surface winding, friend. It is a very smooth winding, free from bumps and many things. Without tension, without no stresses. See, very used plant here. See the speed here of winding speed, friend. This winding speed, screw rotation speed should be synchronized here. Otherwise, there is a lot of tension will be created. Everything should be synchronized here, friend. This is the control panel. You can control all inline equipments, nip roller speed, bubble speed, then takeoff speed, then screw speed, then winding speed. That all speed gets synchronized here, and you will get a good film. Now, extrusion blown film process variable, made temperature. Made temperature play very important role, friend. Here, You have to use the melt temperature above melting point first in all section. Back pressure is very important here, friend. I told you back pressure is essential. Internal air pressure, yes, it is a required 3 to 4 kg per centimeter square. Efficient cooling purpose, efficient cooling चाहिए. Cooling may be ring cooling, maybe mandrel cooling. Just we have seen the mandrel cooling on the no, the bubble is formed on the mandrel, right? It's the chilled one by chilled water. Then lip cooling rings. It may be single lip, double lip. Takeoff speed, that is nip roll speed. Takeoff is nip roll speed. That should be synchronized. Blow up ratio, typical converted film 2:1 and shrink film 4:1 because shrink film always shrink after the application, right? And therefore, the blow up ratio required for the shrink film is higher than the this converter film. Commercially viable, you know that combination are lay plate width and low thickness, high lay plate width, high thickness. Therefore, see now lay flat width for low thickness. Okay. Therefore, जितना साइज लोअर है उतना थिकनेस भी लोअर चाहिए. जितना higher, if you want a higher, weight, having a very strong bag, right? Therefore, you should have a thickness should be very high. High होना चाहिए thickness film का. Therefore, all Jabla bag we are manufacturing by this extrusion blowing process frame, blown film process. Now, if you see here, these are we have seen now efficient cooling, blow up ratio, then low flat width, right? Then if the thickness is lower, it is possible in this case. Now, if you see blown film extrusion, mesh strength is very important. I told you generally polypropylene is blown downward direction, right? And the polyethylene is upward direction. Now, mesh strength related effects are higher mesh strength, steeper fin allow more air to be blown against the bubble without causing the bubble instability, hence higher output. If the polymer having a higher mesh strength, for example, SDP, PVC, or maybe nylon, then steeper film allows more air to be blown against the bubble. You can put a lot of air there inside the bubble without causing bubble instability. Hence, higher output. Now, recycle material. Low mesh strength, hence low speed operation and low output. If you use a recycled material, then what will you have to use? Low mesh strength and also the low speed and low output. Now, if you see the reduction in a melt temperature, if you reduce the melt temperature, it will increase the output. And with internal bubble cooling, the rate can be increased to 20 to 25%. That is a very important frame. Internal bubble cooling, I have shown you. That is the one mandrel is there. It is get cool completely. And over that, the film is blowing at the upward direction. That video we have seen. Internal bubble cooling. And therefore, the reduction in the melt temperature will increase the output. Output can be increased. How much? 25 to 50% also. If you cool the dye or bubble from the inside. Now, LDP blends, highest rates can occur when blow-up ratio is about 2.2 to 2.8. Therefore, low blow-up ratio, not much surface area to cool, hence low output rate. Right. If it is a, see, always higher rate, always give you the higher side blow-up ratio. But if you see the low blow-up ratio, it is not much surface area to cool, and hence the output is lower. Now, the blow-up pin, the defects, these are the defects friend here. See now here, the wrinkles are here. The plastic jabla bag में wrinkles आ रहे हैं. Then what you have to do? What is the remedy for that? The remedy is dirty collapsing frame. Your frame is not proper. It's a dirty one. It is not get oil completely. Therefore, collapsible frame also affect the outer structure. It's a wrinkle. Too much wave tension. Therefore, adjust the tension. Improperly design your ring. Use new earring. Gauge variation into the polypropylene. If you see gauge variation, therefore this also create the wrinkle because thickness somewhere thicker, somewhere thinner, and due to that the wrinkle will be formed along the surface of the film. Insufficient cooling. If the cooling is not proper overall, then there may be wrinkle on the film. Therefore, you have to use maybe sufficient cooling for that purpose to avoid the this wrinkle free film चाहिए अपने अपने को. तो क्या करना पड़ेगा? What you have to do? You have to use the refrigerator air. Try this. If it is not there, increase the flow of air from the compressed air. Third thing, it is suppose it is also not work. Third thing is that reduce the output. You have to reduce the output. Then definitely the wrinkle will be removed. Any question here, friend, about the wrinkle? Now, misalignment between the nip rolls and the die. This also create the wrinkles on the film. Therefore, check this alignment, nip rolls and the die. The second part is fold creases. Excessive stretching between the nip and the roller. Due to that, the fold or maybe creases will be developed there. They reduce the winding speed. You have to reduce the winding speed that time. Nip assembly drive not constant. See, whatever you are using the nip roller, here the speed should be uniform, the constant speed. Therefore, adjust the or replace the drive. A blocking, inadequate cooling. A friend, if you see here, a blocking. Why the blocking occur? Inadequate cooling. Therefore, this block will be take place. Therefore, use better cooling methods. See, generally, many faults are occurring here due to the cooling and temperature of the die or melt, excessive pressure on the nip rolls. Even bad resin, if resin is not good, then blocking will take place. The second part is port lines. The lines are observed on the film is due to the melt temperature too low. Because if the temperature is uniform, then you will get a smooth melt and it is get smooth thickness is there. And therefore, increase melt temperature in this case. Die too cold or too hot in relation to the melt temperature. See now, the die is higher heated as, as per the melt. If you see the melt, then therefore here melt temperature too low, the port line is observed. Die too cold or too hot in relation to the melt temperature, adjust the die temperature. Now splitting. This is what happening in the blown film. Why this happen? Because of the excessive orientation in a machine direction. बहुत निप्रोल बहुत फास्ट कर दिया, स्पीड बहुत बड़ा है निप्रोल का स्पीड बहुत ज्यादा कर दिया है. इट इज हायर स्पीड निप्रोल और मे बी वाइंडिंग का स्पीड बहुत हाई. therefore there may be a splitting. Therefore increase the blow up ratio there. You have to increase the blow up ratio. Then degraded resin, the resin is degraded, then also you have to reduce the melt temperature. And poor resin choice, in such a case also the splitting occur, and therefore ensure resin is suitable for the process or not. Friends, these are some remedies or causes when you manufacture the blown film. Is there any question, friend, here about the blown film plant? Hello? Is there any question here?
No, sir.
We have seen the process, material, die, right? Die design, there are three type of die. Generally spiral die are generally used maximum. Centrifuge die, I told the is the miracle of this, it is get rotated, right? It may be rotated 360 degree, 360 downward on the barrel of the extruder, friend. And therefore, thickness can be maintained there due to the rotation of the die. Okay. Now your spiral die also rotate in 360 degree. We have seen that there are parameters, which is the parameters will generally affect the process. We have also seen the fault, which is observed in the blown film plant, and then we have also the causes and the remedies. We have seen that things. Now we will start the new topic, that is a cast film line, because we have to cover many plant, friend, wire and cable plant, again sheet plant, right? And we have only the tomorrow here. Tomorrow we have to complete all extrusion, and then we will even mixing and this thing, compounding, and then afterward we are going to the blow molding process. Now here, cast film line, I am taking the majority, extrusion frame, because you should know what is the blown film, what is the cast film, because this is also manufacturing. Film is also manufactured by the casting, right? How it is differentiated, blown film and the cast film. Now see here, same, the extrusion is there, friend. It's a chill roll here, right? बहुत ठंडा रोल होता है, temperature may be 4 degree here, and these are the guiding rules, right? See, take up unit. See here, it is not a surface winding. Now see, this is a center winding here. See, there is no another roll here. Therefore, this is center winding. Generally, for cast film, we are using the center winding here. Now you should know the difference between center winding and the surface winding. Surface winding means, I told you, very big roll is there. On that big roll, there are a number of bobbins around like the planet. And once it is get wounded on the bobbin, a specific thickness, specific meter. Then it is get removed by cutting the film, and another one it is started rotation. Therefore, that is a that center surface winding is having a lot of advantage over the center winding. I told you that also. Now the cast film frame, this is a very important plant. If you see here again, material here casted here with the granule. Here see extruder rotating continuously here, clockwise direction. Heaters are provided on the barrel. There is a cast film die is there, friend. It is a, you see, it is also a 90 angle, right? There is a tuck up roll is there. This a floating roll is here, floating roll. This is a guiding roll, guiding roll, guiding roll, guiding roll. This is what is center winding here, friend. Now, see this, the structure of this. This is extruder here. This is a die. Die is however a crosshead die, but the flow is downward direction. Downward direction. It is a highly chilled, highly polished chilling roll is there, right? Now this highly polished. If you see your face, it is a mirror image frame, completely mirror finish, right? And see these rolls are provided here. Then again, these are take-off rolls, nip rolls, both isko, rubber roll and stainless steel roll. Always the material goes on the stainless steel roll. I told you. In the nip roll also, in a blown film, there is also same thing. Rubber roll के ऊपर film नहीं आता है. It is going on the stainless steel roll. Here rubber roll will give the good grip here, and due to that grip, it will get, pulling nature. It will pull. Now here titter bar. This is a powered carrier rolls. So here's titter bar. We can, आपको कुछ कलर करना है, कुछ करना है तो you have to corona treatment देना है. This titter bar is there, which will, give some effect there, right? Whatever the charges, static charges produced, that can be reduced here, right? Afterward here, friend, trimmer is there. Excess of, यहाँ पे ज्यादा है. सपोज आपने को एक 1 मीटर चाहिए, यहाँ पे 1 मीटर ही चाहिए, वहां से 1 मीटर थोड़ा सा ज्यादा आ रहा है, 1 मीटर एंड 10 millimeter again, or maybe 5 millimeter from both sides. Therefore, there is a blade this side and that side. That blade will cut the wave of the film, and again that wave can be recycled, friend. Therefore, trimming can be done. That is 1 meter and a 1 meter. We don't want a 1 meter and extra. Only 1 meter film in the form of sheet you can wound here, friend. So, friend, here rubber nip roll or plastic nip rolls are there, and these are wind up roll, right? And this is very important, friend. This again center winding take place, not surface winding. This is called as a flat film extrusion frame. The mat emerging out of the die leaves strikes the chrome plated chilled roll. This is a chrome plated chilled roll frame. Very highly polished, I told you. A melt is get drop here. See here the die, and the subsequently the film is pulled through the nip rolls. These are the film get pulled here, and trimming blade which will trim the excess of the edge of the film, and then the film is wounded on the winder. See here again the wounder of the wounder. Now, how the die is very important, friend. Cast film die. Cast film die. See here, this is the cast film die. There are 3 types of die generally used in the market. Each have their own advantages also. Now T-tip die. T-type die. T-type die. See, it is a extruder here, friend, and the material go like this. It is get spread this side, this side. Okay. Basically, this also called as a coat hanger die or fishtail die. See, this is a fishtail die. Okay. It is a, see the die shape. It's like a fish tail, and therefore it is called as a fishtail die. See now here, material going like this and like this, and then get sprayed. But see now here, the material coming from this place, and it is a straight going like this. It is spread here also, it is spread here also. Then coat hanger die. See now, this is like a hanger. हम लोग शर्ट और कोट हैंग करते हैं अलमेरा में. सेम कोट हैंगर डाई. Same thing, they have shown here the coat hanger die, pistil die, and the T-type die. Here, what are the advantage of coat hanger die over these two die? Here, the material not get stuck to the die. Therefore, there is no stagnation. There is no sticking of the material to the die. Hence, for a material like a PVC, heat sensitive material, we are going to use this coat hanger die. Coat hanger die is very good for the polycarbonate, PET, even PVC material. This is a very unique, coat hanger die, having a unique applications as compared to the fishtail die and the T-type die. Now, what are the difference between the blown film and the this cast film die? See, blown film, Fred, am I audible to you? Hello? Hello?
Yes, sir. Yes, sir.
See, there are two type of film, I told you, blown film and cast film. Cast film, kaisa hota hai? I have shown you. Blown film, how it is manufactured, I told you. But what is the difference between these two film? Right. See, it is a tougher than cast film. Blown film, because if you see, it is having a more strength. Suppose एक झबला बैग, पॉलिथिलीन बैग हमने बनाया और मार्केट में हम लोग पोटैटो, टमाटो, there may be 5 kg, 10 kg, we can easily pack that, right? That is a tough and the blown film. But if you see the cast film, no, not like that. You don't have toughness, friend. It is just clarity, shine. That is clear. Transparency is here, jada. But it is a more steeper, more steeper blown film. It is a less steeper. You cannot, bend that because it is a, it is a less tough. It is a cheaper. Here, it is cheaper because all Zabla bag UV is looking in the market, right? Having a thickness. See, this is now a very pollution control. They are taking a care of that nowadays in the market. The polyethylene bag, which is have a 50, thickness, right? Micron thickness. That is only used in the market. Above, below is not possible. Only above 50 micron. Pahla initially it was a 20. Now they have changed their norms. Now they have done now 50 micron, right? But people are still, manufacturing 20 or so, 22, 25. There is no any, strict rules are there, friends. The rules are, in India, that is a very, bad, because there is no any rule here, strict rule. If it is a strict rule, then there is a, always we can use the plastic too much, and we can also, our attitude should be changed actually. We are just taking the from the sabji wala or maybe from the shopkeeper, and when our work is over, then we are just throwing. Therefore, there are a lot of animals are there, sea animal, and all fishes. They can eat that, and then definitely they will suffer from the a lot of disease. Even cow, buffaloes. There are many animals are there. This should take care of that, and that's why it is easy to recycle thickness having a more than 50 micron. If the thickness is lower than 50 micron, it is not easy to handle and not easy to recycle also. It is easy, but it takes a lot of effort for that. Therefore, if you see, these are more costly than the blown film. A high output tubular film requires a high tower, a bigger bedding to accommodate, because it is a very high. You have seen now, just now, I have shown you the video of blown film plant here just now, it requires 2 to 3 floor, but here is the require a very less space as compared to this, because there are only the extruder, cast film, their shield roll are there, guiding roll, and the winding unit is there, but nothing is there. Therefore, less space required. Easily changeable film width by changing air pressure. Yes, by changing air pressure, you can change the film width and thickness. Here, not so easy. It is not possible in case of the cast film. Now, less gloss and clarity. See here, cast film we have an excellent gloss and the clarity. This is and that's why we are this is a costly film, friend, right? But these film are used for many application, for uh, to gift wrapping, and many places this cast film are used, right? This is the difference between the cast film and the blown film. uh, Now, tubular quench film. Tubular quench film means which film? Polypropylene, right? Polypropylene film, right? If you see the we have seen now the cast film, blown film, but I told you blown film we have two type: upward blowing and a downward blowing, right? And tubular quench film is what? Downward, right? If you see the polypropylene film that having a clarity more than glass, friend, and it will give a lot of sound also, right? When you just take for the wrapping purpose, it will give the sound. You can easily identify PP film. Now, what are the quench film? How what are the advantage of that? See here, it involves the downward extrusion of the tubular extruded from an annular die. I told you all PVC and polyethylene film upward, but it is what? Extruded at the top, and it's a downward direction, like this here. Now, followed by quenching on water covering the boards. If you see, when the film coming downward, it is get immediately quenched. Immediately quenched means there is a cooled 4 degree temperature is there for cooling this film 4 degree after coming through the die, which causes rapid crystallization, which enhance the optical property. Yes, because you are arresting the chain in a very hot condition, and therefore there's a lot of windows present among the chains, and hence it creates the clarity. It's very simple. If you see here, the chain, there is a lot of gap among the chains here. Why gap? Because of you are arresting the chain immediately by 4 degrees Celsius. 4 degree immediately. It is a very cool, right? And here we are using the direct water cooling, that chilled water cooling. There we are cooling the bubble by the air, compressed air, but here by the water. Therefore, which causes a rapid crystallization, which enhances the optical property. Optical means clarity. Now, the tube is implanted with the air to give a film of a required relay flat width and thickness. Yes, that is we have seen. It is a widely recommended for PP film. Sorry. So, friend, polypropylene film have a lot of application. It is a tubular film, friend. Now see how the PP film is manufactured. It is called as a uh, tubular quenching film, right? Friend, is a quench process. How this polypropylene, see the extruder is here. There is a pressure gauge. Is a die is like this. It's a round one. यहाँ पे आपको ऐसा दिखता है, but it's a round one, right? And the material get here immediately, coming this downward direction. is a lay flat here. See now here. Here's a cooling water. यहाँ पे cooling water जा रहा है. यहाँ से ठंडा पानी डाल रहे हैं हम लोग. ठंडा water. But it's chilled water, friend. Chilled water. It's a collapsible board. See the collapsible board is like this, and this is a water level. See the water level here. And is here nip rolls. See nip rolls under the water. Nip roll under the water. See here, and it is a get here quench like that. And see here, due to the it is a get lay flat. See lay flat width is here. It is a get again by guiding. And here is again a winding road is there. But see the temperature of this. It is a 4 degrees Celsius. 4 to 5. Remember this thing, and therefore the chains are get. See, we are putting here also the chilled water. Yape. Immediately after the when it is coming out, and therefore it is called as a TQPP fill. मार्केट के अंदर इसको क्या बोलते हैं? TQPP fill. T from tubular, Q from quench, and PP fill. TQPP film, the name is the market. Why it is downward? I told you. It shows the shear thinning property. Shear thinning property. We want very clarity. This gives the too much clarity as compared to the polyethylene film. Right? Polyethylene film, we are just blown upward direction. See here, extruder is a top. Extruder यहाँ पे रखा है, and it is downward. Film is a downward direction. It's the main difference between the polyethylene film and the PP film frame. See, the orientation of film. Orientation of film by the stretching it under the heat is widely applied to the film, PP, polystyrene, polyamide, and PET to improve the clarity. Therefore, to improve the clarity, impact strength, and the barrier property. Barrier means optical property also. Then basics polystyrene film in its non-oriented form is brittle and has only limited use as a dielectric in capacitors. When biaxially oriented, the film is tough and can be thermoformed into the crystal clear tubes, trays, larger atoms such as the cake covers. See, these are the benefit of the biaxial oriented film and non-oriented film. This is used only for dielectric capacitor, but this is used oriented, biaxially oriented, not axially, biaxially oriented, clear tube, trace, larger atoms. The largest application of oriented techniques, however, it is in the manufacture of PP film. I told you, friend, PP film is largely used in the market. The main process can be divided into linear and tubular. Right? Linear means linear. Tubular means bubble-like. Now see here how the linear and tubular film take place here. See the extruder here. Is a casting rolls are there. This is a die here, friend. Heated zones are there here. This sequential orientation process of the see this is the orientation. Differential nip rolls are there. See here, forward draw. Heated zone. See, after coming also again heated zone here. Then again heated zone nest here. Second heated zone. And if you see here, here is a annealing take place, frame. Annealing. It's a draw down. It is ये खींचता है इसको. ये इसको क्या कर रहा है? खींच रहा है. Right. And here is a wind up unit is there. See, Steiner clips are there, which will get orientation. Therefore, orientation this way also and this way also. See, the orientation take place in two ways here. And therefore, here you will get a more strength here. Strength कैसा इसका बढ़ता है because of the this way. You are orienting here also and here also. And here is after cooling, you have to apply here cooler here. and just winding take place here, friend. This is called as a biaxial orientation take place. All right. This way also and this way also. The film get more strength here. Now see also the same thing happening here. So they are also shown again here. Forward draw. Right. Multi-layer film. We'll now tomorrow we will cover the multi-layer film frame. Now we have seen now this blown film and cast film and a biaxial tail TQPP film. Now tomorrow we will cover multi-layer film and we will also start the seed plant tomorrow. Okay. We will meet tomorrow at 6:30. Okay. Are you with me, friend? Hello.
Yes,
Am I
sir.
audible?
Yes, sir.
Yeah. We will meet tomorrow at 6:30. Again, we will cover tomorrow. I told you seed plant, multi-layer plant. Right. How the multi-layer film. There is a 7 film come together. Right. That is for the barrier purpose. Right. For the now see the tomato ketchup. We are putting one that pouch, but the pouch is not a single film. There may be 3-4 films are there. Why that films are used? Tomorrow we will discuss. Okay, and how that films are manufactured, we will see tomorrow. Okay, we will meet tomorrow, friend. Good night.
Okay, sir. Thank you. Good
Yeah.
night.
Good night.